One of the herpetologists fears that pollution might be affecting the natural growth of the pythons. Do you think this sample result is unusually small? So there's a couple of ways to go about it. One, you can look at the percent, calculate the percent for getting, what's the percent chance of this happening? And if it's small, yeah. Or calculating how many standard deviations away from the mean. Doesn't matter, either way. But we still need to check conditions to be able to do that. So for the conditions, for independence, we needed to either say that it's each snake is independent or a random sample. Well, in the problem, they collected a random sample. Next, we need to check for population. Do you believe that 30 adult pythons is less than 10% of all adult pythons? Again, remember, you're going to hate writing conditions. I hate writing conditions, but if you don't get in the habit of doing it now, in the practice and in the examples and stuff, when it comes time for the test, you are going to forget. All right. Next, we need to check for our large counts. Do we have a large enough sample? And this is using the CLT, central limit theorem. If we have a large enough sample, then our sample needs to be 30 or higher. And our sample size is 30. And 30 is greater than or equal to 30, so that condition is met. So first I'm going to do it with the standard deviations. The standard deviation of X bar is the standard deviation of our population divided by the square root of n. Standard deviation is 2.3 feet divided by the square root of 30. And I get a standard deviation of 0.4, we'll say 42. If I were to look at my normal model now, here is the mean of the population, and that's 20.5. The mean of my sample was 19.5. Actually, I'm going to do it this way. If I go one standard deviation this way, I'm going to get 20.08. If I go another standard deviation, I'm at 19.6 something. I haven't even hit my mean of my sample. I'm more than 2 standard deviations away. So we could say, since it is more than 2 standard deviations away, that is a relatively small sample mean. Okay. Questions? So that's one route you could have gone. If you went with the probability, once we have our standard deviations, we could have gone with, all right, so here's my sample mean, here's my population mean is 20.5. 19.5 is over here, so I'm looking for the left side. So that means my lower, I can use a normal CDF to find that proportion, or the probability, I should say, would be 999, negative 999. My upper would be 19.5. My mean would be the 20.5, and my standard deviation is 0.42. And I put that in my calculator and get the result. And I get less than 1%. A relatively small right? So either way would have given you the idea that you have your sample mean is small and is unusual. Okay? Questions? All right, second one. It is generally believed that electrical problems affect about 14% of new cars. An automobile mechanic conducts diagnostic tests on 128 new cars on the lot. What's the probability that in this group, over 18% of the new cars will be found to have an electrical problem? So we want the probability that P hat is over 18%, 0.18. That's what we're looking for. Well, we know that P is equal to 0.14 because that's what they give, affect about 14% of all new cars, and that we have an N of equal to 128. Notice that this time they didn't give me a standard deviation. That tells you you're going to need to use the N, the P times 1 minus P divided by N to find the standard deviation. So this is a proportion. All right. So now let's check. So we want that P hat is the 0.18. Conditions. Okay, this one. Same thing for independence. We need to have a random sample. Okay, does it tell you that it does a random car? You have to make the assumption, and that each car is independent of the other. So assume the cars are randomly. Chosen, not chosen has 1 O. Also, do you think 128 new cars is less than 10% of all new cars? Yeah. Now for our large counts for this one, this is where we need to have 10 successes and 10 failures, at least. So N times P has to be greater than or equal to 10. So 128 times 0.14, is that greater or equal to 10? And that's 17.92. And then N times 1 minus P has to be greater than or equal to 10. Same idea. 128 times 0.86 is going to be greater than or equal to 10. And that's going to be 100.08. 110.08. Did I subtract that correctly? Okay. Conditions are met to apply a normal model. All right. So now make a little sketch of it. So we are looking for, so if this is our mean, is 0.14. 0.18 is going to be over here. So I'm looking for the right side because it's got to be greater than. So I need to find my standard deviation. My standard deviation of p hat is going to be the square root of p times 1 minus p divided by n. So that's the square root of 0.14 times 0.86 divided by 128. And that gives me 0.031. All right, so lower bound is going to be the 0.18. Upper will be 999. The mean of p hat is going to be the mean of p. Because the fact we've allowed us to use the normal model, they're going to be, it's an unbiased estimator. So 0.14. And the standard deviation of p hat is 0.031. Comment in there. And I get about 9.8%. So there's a 9.8% chance that of the group of 128 cars, that over 18% we're trying to determine that they will be found to have electrical problems. Questions? Anybody got questions? Guys, remember at home, if you type in the chat, you can use eSchool. Is that for the first one? If you type in chat, guys, remember I can't see it, or it doesn't let me know. Bring this up so I don't keep banging against it. All right. Questions? All right, so now your quiz is tomorrow. It'll be at some point in class. You guys here are going to be doing it from home. Okay. What's on this agenda for tomorrow? Is an STS discussion. So it'll probably be the last, I would say, 20 minutes of class. Okay. So you're going to need to go to exam.net at 1 or at 8:40 and do it from 8:40 to 9 o'clock. Okay. So mark it in your calendar. Don't forget. I'm looking at you. All right. Okay, so let's do Stats Medic. Guess the mystery proportion. I sent an email to each of you yesterday for the Stats Medic for today. in which it gave you how many red beads were in your jar. Okay? My printer's going out, the ink in my printer's going out, so we'll put prints. Okay? So I gave you the amount that were red for you. So this first page, I'm pretty much going to let you do it on your own. The second link in there that I sent in it, the link in the email is for a Google form for your confidence interval. Okay? And we can see who gets closest to the actual one. All right, so I'm going to give you, this is not going to take but a couple, I'll give you about 5 minutes on this first page. Okay? Here's the first page. While I wait for the printer to get the rest of it. start going through this just very quickly. So hopefully whatever the value I gave you is your point estimate or proportion. Okay. So let's talk about 5 and how you write it, and then 6 and so forth. Then we're going to talk a little bit more about what is a confidence interval. There is a way to write how confident you are. So on this one, so Lydia, what was your percent? You said how confident you were. 65. 65. So I am 65% confident that the true proportional mean is between this one and this. That's what that kind of means. All right. Julia, what percent did you say you were? Oh, you ever got that part? Okay. Aiden, what did you say you were?
45%.
45% confident. Okay. So you say we are, I am, whatever percent confident. The true proportion mean is between this and this. Okay. Does that mean it is in there? Not necessarily, no. All right. One of the groups got this is their, and this is how you write a confidence interval, guys, is it's in parentheses. It kind of looks like a coordinate pair. How would you find their point estimate if this was their interval? It went from 0.27 to 0.33. How would you find their point estimate? Find the average. So if this is like A and this is B, it's going to be 0.27 plus 0.33 divided by 2, and that comes out as 0.3. The margin of error, MOE, is found by subtracting those. It's the half of the distance. So the point estimate is the middle value. The margin of error is the half the distance. So if I take 0.33 minus 0.27 and divide that by 2, it gives me my margin of error is 0.03 plus or minus my point estimate. And then you can answer the last question, because it'll depend on your interval. All right. So before we go on to the next one, I want to talk about it real quick. And I need the board. Podcast. Okay. So with this percentage, like you said, you were 65%. You said you were 40%, right? 45%. Now, is that a percentage? Meaning there's a 65% chance that the true mean is there. Is it a probability? So let's talk about it. All right, I'm going to take this out of here. And I need to make sure that you guys at home can see. I might actually sit this into me. board on there. Trying to get it to. Second. You guys at home be able to see it too. What I'm gonna do. There we go. It's not the best, but it'll work. Okay, so I need a volunteer. Coming towards the back of the room. Will you? Touch. Okay. This is what a confidence interval is. All right. So let's say I have a dot right here. I want you to stand up, go to the back of the room. There's fine. I want you to hit the dot. Can you hit the dot? How confident are you? Okay, I'll make it easy. I'm gonna make it a circle. Look at it, this as like 60% confident. Can you hit it? Yeah. Not hitting Aiden though. Aiden, you may want to move. Okay, so this was 60% confident that she can hit the circle. All right, you're gonna keep going.
No.
Aiden, you may want to move. Let's say this is now 80% confident. All right. All right. So still at 80% confident. Okay. Let's say that this is 90%, 95% confident. Okay, so that's 95%. Let's say that this is 99%.
Just hit the board.
You just have to hit it inside the big circle. You're throwing it too hard.
Okay, hold on, I got it.
So hold on. So even at 99% confident, does it mean the truth? It's going to actually happen? No, we're just more confident because what's happened to our interval? Bigger. Don't throw so hard.
Okay, I'm gonna get the second.
Bullseye.
Don't hit my Dr. Who stuff though. Oh, see, not so hard. All right. That's what a confidence interval is, guys. It's not a percent chance it's going to happen. But as we make our interval bigger, we have a higher likelihood of hitting that true mean that we want. That's all it is. All right. I have to try to figure out a way. I do this every year to give you an idea of what a confidence interval is. All right. So now let's talk about it. So there's an applet for you to use. Okay. It's on your page. So use the confidence intervals applet.
Miss Levitt,
Yes.
How do we find an interval that we think would like contain the true proportion?
Well, you never can guarantee it. That's what we're going to look at. It's over many, many samples of the same size. We're going to be, so if we took many like intervals. And normally what we would do in here, guys, is we would have like, we do M&Ms. And I give you each a package of M&Ms and you try to figure out how many orange ones are in there. Or yellow ones. And then we put the intervals all on the board and we see how many of them actually met the true proportional mean. Okay, there's no way to guarantee. And the way we're going to calculate it is we're going to talk about it involves z-scores, our sample proportion, and a few other little things. Okay.
Mrs. Lovett,
Yes.
how do you find percentage though for number 5?
Say that again. It's a little louder. It's hard for me to hear you.
How do you find the percentage for number 5?
Number 5. I mean, on this part,
Yeah.
that was your percent. You had to come up with a percent. Okay. And this is just how confident were you?
How do you find the percent from your margin of error? What's the calculation for that?
It involves using a percent value from a table. And we will talk about those more a little bit later. At times our percent above and our point estimate. Take our your point estimate plus or minus what's called the Z critical value. Okay. We will do that a little bit later. Just
Oh, for number 7, how do I know if my interval supports what I'm finding based off like the point estimate mark there?
so just based on is this 0.25 inside your interval?
Oh,
That's it.
okay.
If it's inside of it, then it supports it. If it's outside of it, it denies it. All right, let me try and get this. It should be on this page. Okay, you guys at home should be able to see the confidence interval 1. So it wants you to click sample. And it gives you one. So did this one capture the true mean? The first one, okay. It's bright green, I can't see. Is this word sample 2? We keep going. Did all of them capture the true mean? No. And if we look at them, there's possibly like 20 of them up there. One of the 20 didn't make it. So 19 of 20 is 95%. So 19 out of the 20 that we had did capture the true mean. All right. Hmm?
So how is that? So I have 25. So that that's support the interval.
Mhm. Mhm. Yep. Okay. So as we work through this, when you get down to number 4, it says watch your confidence intervals as you drag the confidence level from 95 to 99 without resetting them. What happens to the interval when you raise the confidence level? What happened to the interval? It got bigger. Does this make sense? It's like our big circles. You're more confident that that true proportion is going to be in there. As you increase the confidence level, the intervals get wider. So Basically what happens, guys, is when you increase that confidence level, you're increasing your margin of error. So when the confidence level goes up, the margin of error also goes up. Okay. Interpret the confidence. So let's talk about interpreting. You're going to be asked to interpret two things. So previously we interpreted the confidence interval. This time we're interpreting the confidence level. There's two different interpretations. So in this one, for interpreting the level, says if we make many intervals, 80% confidence intervals of the same size, we would expect about, and this, what was this level? 80%? 80% to capture the true proportion mean. Okay. Now, what happens when we change our sample size? The interval narrows, so our margin of error narrows. So if we increase the sample size, the margin of error decreases. You do want the smallest interval, because when they use these intervals, as you'll see in the skew script and things, it's for like, let's see, how many of this should I buy? You know, I don't want to overbuy, because then I'll spend extra money on things that I don't need, and I could have used that money elsewhere, but I don't want to underpurchase either. Oh, I thought we got out of 55. Nope, we're done. Okay, finish this up. Okay. Huh? Yeah, I forgot to. All right, so finish this up. We'll talk some more tomorrow.